Very good. So, thank you for having patience with us. This is Jeff Campbell actually from Sefar. He is sales manager for screen fabrication, and he will tell us about ultra fine line conductive screen printing today and how it all starts with the right screen. So, over to you, Jeff.
All right. Thank you, Christoph. Thank you, everyone, for joining today. I appreciate you guys' attendance. We're happy to talk to you about some of the technological advancements we've had in the last few years in the screen printing industry, specifically with the fabrication of the screens. Christoph's going to be my assistant today and help me move from slide to slide as we've, again, had a little technical issue. But we'll start with a historical progression here. Before 2010, going back 12 years ago, 100 micron features were considered cutting edge in screen printing. That was basically the finest we could go to and sort of the gold standard in the industry. By 2015, features were pushed to 70 microns by advancements in technology in the mesh emulsion materials, as well as the processing that we have a hand in. By 2018, we were able to produce 40 micron features for multiple customers in production, not just in a lab. Today, we're reaching sub 20 micron features. Again, in this presentation, we have several pictures of some of our current work and the prints from that work. Sefar is able to control the whole process from film output to press, and we've had advancements in technology in pretty much all those areas, from increased film processing to, again, the materials to make the screen. The challenge for screen printing always is detail versus open area. We have different threads per inch in our materials, which you can consider like dots per inch on a computer. The more threads per inch you have, the more detail you receive. However, the more threads per inch you get to, it becomes congested and features can fall on those threads. So it's an ongoing struggle between those two, open area and detail. So also, the emulsions have improved to finer capabilities and advancements in our screen making, which we'll go through today. Christoph, if we want to go to the next slide. Again, back in 2015, 2018, the smallest threads that we had were about 18, 20 microns. They've come down to about half that size in the last 5 years or so. Right here, we have a nice picture of a human hair, which are typically around 70 microns in diameter. And the finest wires that we're using these days is this 11 micron wire. You can see the comparison there. It's about 1/6 the size of a human hair, which is very small. The smaller wire makes it possible for us to get the open area without giving up detail, because we can still have 500, 600 per inch and still have a nice open area, giving us nice flow for the silver conductive paste and finer detail. Next slide. Okay, here I've included a nice calculation for deposit, as well as fine features. A lot of people want to get very thin deposits too. This is a good calculation for being able to figure out, using the open area percentage of the mesh and the thickness of the fabric, you can come up with your theoretical wet deposit. Next slide. Okay, here I'm showing the difference. You can have a mesh with the same number of threads per inch. Here we've used 325 threads per inch mesh with different wire diameters, and shown that you can get a very different print thickness out of the same fabric by having different wire diameters. Again, with two wires laying on top of each other, you end up with a thicker deposit if the wires themselves are thicker. But you can also see how it affects the open area. 50% open for the 0009 wire versus 29% open for the 14. So again, it gets much more congested when you get that bigger thickness. Next slide. Here's just a visual representation of that. You can see the 32509 and how the fatter threads create a smaller opening. If you look top to bottom, you see a very big 50% open, half is mesh, half is opening. And by the time we get to the bottom with the much larger threads, you get less than 30% open area. Next slide. So I wanted to discuss some of the other advancements. Several of our mesh manufacturing partners have come up with specifically a